shows how heat moves through solids.
Heat transfer through conduction works better in metals than any other solids because it has more free electrons.
Solids that cannot conduct heat as well are called insulators. Good insulators are solids like foam.
The movement you see in the lava lamps is due to convection currents. Solid wax at the bottom of the lamp melts when it is warmed by a light bulb. It becomes less dense than the liquid, which is oil, and moves upwards. As it rises, it cools, becoming denser and sinks back down again.
Because there are no particles in space, heat and light have to travel in waves. This is called radiation.
This light bulb is 95% efficient, as 95% of its energy is transferred into useful energy, which is light, and 5% is wasted as heat energy. We show this on a Sankey diagram. 100% of the energy goes in, 95% is gone out as useful energy as light, and 5% is wasted as thermal energy. To calculate efficiency, we divide the useful energy going in, or the useful energy out, and the total energy in, and we then times that by 100.
Electrical energy is the transfer of energy when an electric current flows through a circuit. Current is the flow of electricity, or the number of electrons in a circuit, and you use an ammeter to measure it. It is measured in amps. It doesn't get used up as the electricity passes around the circuit, because there is always the same number of electrons in the circuit. This is how much energy there is in an electron, and you use a voltmeter to measure it. It is measured in volts. Voltage does get used up as the electricity passes around the circuit, because voltage measures how much energy there is in each electron, and the energy in each electron gets used up by bulbs and other parts of the circuit.
These are the symbols of the circuit
that you're going to need to know. So this is the cell, and this is the battery. This is an open switch. This is a closed switch. This is an ammeter. This is a voltmeter. This is a diode, and this is a bulb.
Go.
Circuits can be connected in series or parallel. That's a series circuit, and that's a parallel circuit.
What's the difference?
One's in parallel.
Power sources are the things that we can generate electricity from. For instance, fossil fuels are a power source. There are 11 main power sources you should know about. The fossil fuels, coal, oil and gas, nuclear energy, wind, solar, geothermal, hydroelectric, biomass, wave and tidal.
Solar energy is a renewable energy source. It's expensive to install but fairly reliable. It's long-lasting but can be quite big.
Fossil fuels.
Fossil fuels is when burning coal and oil to form energy. Burning them releases sulfur dioxide, which helps cause acid rain. Acid rain damages buildings, kills plants and pollutes rivers and oceans.
Nuclear energy
is an interesting energy source. It's non-renewable but doesn't release anything. It can release radioactive.
Go.
Wind energy.
Generated from wind powering a wind turbine. It's renewable, unreliable though, not always windy. It's expensive and ugly in the countryside. It's long-lasting but requires a lot of space.
Tidal energy.
It's renewable, expensive to install. Large amount of electricity produced depends on the tides. It must be built across an estuary, which disturbs the flow of the river.
Biomass.
Biofuels do emit CO2 but are carbon neutral, then renewable.
The electricity that's produced by the different types of energy are transported by power companies through power lines, mainly the national grid. It is transported by power lines and power cables that go from power stations to buildings, like factories, homes, schools and businesses. Step-down transformers. Step-down transformers are mechanisms that reduce the voltage of the electricity before it reaches the consumer, in order to produce safe energy for the consumer. Step-up transformers are mechanisms that increase the voltage of the electricity before it reaches the consumer, in order to decrease the energy loss.
There are many different types of waves. For example, light waves, microwaves, sound waves, radio waves and many more. There are two types of waves, transverse and longitudinal. Transverse waves oscillate at right angles to the direction of the waves that they travel. Longitudinal waves oscillate in the same direction the wave travels.
Reflection. Without reflection, things could not be seen, as objects reflect light waves towards our eyes. Smooth and shiny surfaces give a clear image of the reflection. Sound waves also reflect, not only light waves. There is a law of reflection. When any wave reflects from a surface, the angle at which it is reflected is the same as the angle that it strikes the surface.
Diffraction. Diffraction happens to waves as they pass through gaps around corners. Diffraction is at its greatest when the gap is the same size as the wavelength of the wave.
Refraction. Different waves travel at different speeds. Light travels much, much faster than sound waves, which is why during a storm you see the lightning before you hear it. They also travel at different speeds through different mediums. They travel slower in air than in a vacuum, slower in glass than in air.
The normal. The normal is an imaginary line drawn at a right angle to the boundary between the two mediums.
Gamma rays have the shortest wavelength and they're also used for the treatment of cancer. X-rays are the next shortest and are used for photography in X-rays. Ultraviolet is light we can't see and it's used for lighting. That's the next shortest.
Visible light is used for laser surgery and is the light that we can see. Infrared is used for shortwave, short-length communications, cooking and remote controls. Microwaves are also used for shortwave communications and cooking. Radio waves are used for long-distance communication.